Hi, everybody. Actually, let's go back to the beginning. So we are recording this webinar so that it's available for anybody who might not be able to stay on the same thing, the whole thing, or also so that others will be able to take advantage of it. So I actually wanted to, how come it keeps moving? So welcome everybody to the kickoff webinar for the dkNET-NURSA Challenge. I'm Marianne Martone. I'm one of the PIs of dkNET, and Ko-Wei Lin, who's the project manager, is also here. And we'll be switching off during the presentation. So the way the presentation is organized is we're going to go first over what is dkNET and why are we here? Why are we using dkNET for this challenge? And the second part will focus on the challenge. What is it? Why are we doing it? The task itself. And then getting started in using dkNET in order to address the challenge question. So first of all, just a quick overview of dkNET before we get into the details. dkNET is the NIDDK Information Network. This is a community resource that was set up by the National Institutes of Health, National Institute of Diabetes and Digestive and Kidney Diseases, as a way to be able to connect together researchers across the NIDDK portfolio, and also some of the very important centers that they have instantiated to support research in their area. And one of those is, in fact, NURSA, the Nuclear Receptor Signaling Atlas. So this is an open community resource portal. It's directed towards basic and clinical investigators. Its basic function is to provide an easier way for researchers to access collections of diverse research and clinical information that are contained in databases. And I think that's one of the most important aspects of dkNET. Unlike Google, which accesses web pages, dkNET accesses not only the page that describes a database, but also the contents of the database. And this being able to search inside of databases is a challenge. Not even Google has entirely solved it yet. So dkNET is one of the ways that NIH is working to make sure the dozens and in many cases hundreds of databases that are set up that contain information are easily searchable. So what are the types of things that are in these databases? Some of them are data sets or provide access to data sets. Some of them provide access to materials like organisms or vectors, software tools or other types of tools and services that are there to support research. One of our most popular indexes is funding opportunities. dkNET does a lot, not only to look at the major NIH opportunities, but also smaller pilot programs and things that currently don't really have a centralized database, and of course the biomedical literature. Another important function of dkNET is not only to provide these tools to researchers so that they can search for these things, but also as a communication forum to help NIDDK supported researchers keep up to date with what's going on in the community. Some of these things come from NIH, but others come from the communities itself. So again, pilot opportunities, conferences, papers, dkNET is very happy to promote these to the community. So why are we partnering with NURSA on the NIDDK challenge, dkNET-NURSA challenge? First of all, this is a fun way we thought to learn how to use dkNET and some of the basics about searching for data, which is a little bit different than searching for web pages, but also data curation. I don't think it's a surprise to everybody that there's an increased emphasis on data sets that are produced inside of laboratories, and that these things need to be handled a little bit more formally and in better ways than we currently do. So those who participate in this challenge will get a little bit of instruction on at least a simple curation strategy for dealing with these data. One of the most important motivations is also to try to create a strategy for dkNET to deal with the big data issue, or NIDDK to deal with the big data issue. Researchers know there's a lot of emphasis on big data, and big data typically means big science. There are these big, large, coordinated projects that have been funded by many different institutes to garner large, comprehensive data sets that allow big data analytics and analysis to be used on them. But a lot of researchers don't like the fact that all this money goes to big science, and there is still a lot of reason to support individual R01 investigators. So actually, the transcriptome and transcriptomine are good examples of how we can take these smaller data sets that are being produced by the community across many different experimental paradigms and merge them together to create a big comprehensive data set. So this is an experiment also within NIDDK to see how well the community is going to support this, because there's a lot of value in these integrated data sets that come from the efforts of a lot of individual researchers rather than from these big science. Also, again, to introduce the community is a good opportunity to NERSA itself. NERSA is an extremely well-run and important resource. They have created something called the transcriptomine. And some of you may be aware that just very recently a paper came out that described transcriptomine in science signaling. And this is an example, and it goes into detail, again, how this sort of community curation of these small data sets can be used to produce big data. So we are very pleased, actually, to have Scott Oxner from NERSA, who's going to give us a little bit of detail about what they're exactly looking for and how it is that transcriptomine works. So let me turn this over to Scott, if you could unmute yourself. He will describe the dkNET-NURSA challenge task.
All right. Can everybody hear me first?
Yes.
Okay. So to kind of reiterate what Marianne said is that NERSA is really largely NIDDK funded organization that serves pretty much as a warehouse almost for any and everything nuclear receptor NR ligand or co-regulator related. And one of the tools that we've developed is called transcriptomine. Transcriptomine is a database of gene expression data sets, largely from microarray and RNA-seq. It's currently around 40 million data points over many different tissues and many different receptors and co-regulators as its focus. And largely this has been easily put together, I would say, compared to some of the things we're going to ask for the challenges, because there's two large public repositories for expression data, GEO at the NCBI and Array Express at the EBI. So what we would like to focus this challenge on is to, first of all, identify other omics types of data sets in the literature, and if they exist in a public repository, to get those accession numbers. The ones that we're mainly interested in are the post-translational modification type data sets, where you're looking at global phosphorylation, for example, metabolomics, where you're looking at global physiology, and interomic, as well as protein-protein interactions. And most of these three types of data are going to be mass spec. The challenge here is that there's not any well-characterized repositories for some of this data as there is for gene transcription, with possibly the exception of the metabolites database for metabolomic data. So what we would like to, how do I go ahead and skip this? Okay, so what we...
Oops, are you there?
Are you there?
Yeah, I'm here. Can you hear me?
Yes.
Okay, so we would like the data sets first is to focus on nuclear receptors, whether that is a perturbation such as a knockout, a knock-in, overexpression. Really what you're looking at is differential data sets, differential phosphorylation or metabolomics or protein-protein binding in the presence or absence of a ligand, for example. And these are the small molecule such as ligands, drugs, synthetic organs that are known to impact nuclear receptors or co-regulators. So that would be one requirement. And a list of these small molecules, as well as the receptors and co-regulators themselves, are easily gained from the NERSA website. Next slide, please. Oh, sorry, go back up. I think one of the biggest problems that we discovered with getting the transcriptomic data was an issue of false positives. So for example, if you're doing a literature search and you're looking for a ESR1 synonym for estrogen receptor, you may get a positive hit if you're searching PubMed or the GEO, for example, but the data set itself may actually be, for example, a notch knock-in versus a wild type, and they just happen to mention the estrogen receptor in an abstract. And so now you've identified this through a keyword hit, and you've bothered to read the abstract and possibly even gone into the paper before you realize this is not really a nuclear receptor related paper. So I think beyond identifying the data sets themselves and if they are deposited in public repositories, the second part of the challenge is going to really be eliminating as best as we can the false positives. Any questions?
I'm not seeing any. So we are next going to go over a little bit about how to get started. And at any point during this, feel free to unmute yourself, or I think there's a function to raise your hand if you want to ask a question. The rest of it is really designed to help you get started. So to sweeten the pot a little bit, and also to we hope encourage especially graduate students and postdocs to join. We have a very generous donation from SciCrunch. SciCrunch is a spinoff from NIF of $500 cash prize to those who individuals or teams that actually produce the highest number of quality data sets. But any of the first 20 participants, individual or groups, will also be given a $50 gift card. So we really are hoping that this gets advertised, that if they're undergraduates, doesn't really matter, whoever you think might be interested in it, as an opportunity to spend some time with dkNET and also other search tools to help NERSA in their quest to identify these data sets. And as you already heard from Scott, it's not 100% straightforward. That's another reason why we're going to give you some financial remuneration, is I think anybody who starts to try to search for these things will very soon get frustrated by how difficult it currently is. dkNET and the standards that it's trying to help promote hopefully will make this easier over time, but this is also why good data curation is absolutely necessary. So I'm now going to turn this over to Ko-Wei Lin, who's going to show you how to get started with the challenge. And then we'll spend the last time going through a little bit of how you can start to use dkNET to ferret out some of these data sets. So Ko-Wei?
Yeah. So join the challenge. There's easy 4 steps. First, get an account and sign up for the challenge. And then you start to search for the omic data set and identify whether this is the data set that you target, and do the biocuration. The third step is submit the data set, upload to the system that I will introduce later. And 4, then you can win a prize if you are the first 20 submission and who submit the correct data set. And then later you can invite your friends and colleagues to join the challenge. So how to register for the challenge? First, you go to the dkNET.org, it's our homepage, and then scroll down a little bit. You will see there is a advertisement of the dkNET Dataset Challenge. And then you just click the Join Challenge or Go to Challenge Page tab. Then it brings to you the challenge page. On the right side panel, you will see Join the Challenge. For people who hasn't have dkNET account, you need to open account first. After register a new account, you will receive an email and you need to verify through that email and then come back to the dkNET page, login back to the challenge page. After that, under the join challenge on the right side panel, you will see join the challenge and then just click it. And now you are in the challenge. Then the next step is on the right side panel, under download worksheet, you need to download the worksheet for your biocuration. So it is an Excel file. After you download, you open it. There are 8 columns that you need to fill in. For each data set, you need to fill in the type as we introduced, as Scott introduced in the last few minutes. And then you need to input the pathway and also biosources, such as which cell line it's come from and which like other biosources come from. And the 4th column is about the literature it's cited. You need to input the PubMed ID. For the 5th column, you need to fill in where do you find this data set? What is the repository of this data set, the name of the repository, and if there is any accession number from this repository data set. You need to provide a URL, and if it's not available online, you need to provide individual lab name or other information. On the next column, you just tell us whether you're using dkNET, you use this to find this data set, or you go through dkNET to other repository to find this data set, or you're not using dkNET, you're using other resource. The next column is, if you are using dkNET, you just provide us a workflow, how do you find it? And the last part is, if you have any feedback about using dkNET while looking this data set, then you can write down here, and we will introduce this in the point system. You actually will get bonus point when you're using dkNET and give us feedback.
Okay. So that was just a quick overview. The spreadsheet might look a little intimidating, but it really isn't. There's only 8 fields, and a lot of that has to do with dkNET itself. And we have established a fact page and a help page to help people get started. One of the questions that we got is, do I have to use dkNET? And the answer is, we'd like you to start there, but very quickly you may end up on a certain line of inquiry that can best be answered by Google or PubMed or Google Scholar or whatever other sources of information that you have. So really, that's what dkNET is designed to be. It's designed to be a gateway into a lot of these different sources of information. But just like Google lets you search over many, many different web pages all at once, we let you search across many different databases all at once. So we wanted to give you a few tips without giving away, some of the Easter eggs that we know that are present in dkNET, which we think would actually meet the challenge, on how to get started with dkNET, how to search it, and then go through an example or two of the sorts of things that you can do. So again, if there's any questions, just raise your hand or unmute yourself and ask a question at any time. All of these tutorials, again, are available online. One thing that we warn you is that dkNET is under active development, and one of the problems with these tutorials is that almost immediately a change is made, and it may not always look exactly as it shows on the tutorials, but please let us know about that. So I wanted to give you, first of all, just sort of an overview of how dkNET organizes its information, because searching, as I mentioned before, for data by a dkNET, a search engine across multiple databases, does not work exactly the same as a search engine for online documents. And the types of queries that you do and the best and most effective way to use it is not always apparent. dkNET has tried to balance between the complexity of the entire universe of databases that are available to biomedical researchers. Right now we cover about 200 or more of these, versus the subset of ones that might be particularly interesting to this community. So we've organized actually dkNET into 3 indexes. And if you look at the top of dkNET, you always see that there's community resources, something called more resources, and literature. We have spent a lot of time thinking about these names, but again, your feedback, if there are better ones, would be appreciated. The community resources really are a subset of those that are available over here that are really specialized for NIDDK. These include the centers that have been established by NIDDK, so NURSA, for example, their databases are some of the things that we search, but the Diabetes Complications Consortium, there are a bunch of these centers, and we're constantly adding new ones as NIH commissions new ones. So these are a subset of resources. The more resources is these plus all of these other ones. And because the community resources is a subset, we're able to provide views into them and search tools that are more focused on the types of things that NIDDK provides for their researchers. The more resources, because this covers everything, is more general and more generic and requires a different strategy. We also provide, however, a search into PubMed. We provide additional tools on top of what PubMed provides. We tend not to replicate exactly what they have. But the good news is that when you do a search through dkNET, you search all 3 of these simultaneously. So being able to switch across these tabs, you don't have to redo your search in literature or more resources. That is already done for you. But that's why it's very important to keep this in mind, because you often maybe jump into different parts of dkNET. They might look a little bit different, and that can be a little bit confusing. So that's why I like to start with this slide. This next slide also kind of gives you an idea of the real power of structured information that's contained in databases, but also how you can use dkNET effectively. dkNET operates with a keyword search, just like a Google search engine, just like PubMed. You go ahead and you search it, and it looks for matches for that keyword. We have some enhancements that you'll see shortly about how that works. But because this is structured information in the database, we know a little bit about the types of information that are available for each query. So once you do a query, it says, well, I have information in community resources and more resources and literature. But if there is a hit in community resource, it can say, and I know that those hits are in these very specific categories. And once I select these, there may be additional categories that are revealed. So it's a faceted search, and you can use these facets and filters to help refine your search. We find, because of the nature of the technology that's available and the nature of data search, that in fact the best way to work with dkNET is to put your general term in first, see what's available, and then use this progressive refinement using the tools that are available to you. dkNET performs less well if you load the search term with a bunch of generic things in it, because of the way information is structured. It might not detect what it is exactly that you're looking for. It might not give you a hit when in fact there's a lot of relevant information if you actually use this progressive refinement. So it's always good to kind of keep this view in mind, that this is in fact structured information inside of a database, and therefore there are different types of search strategies. So we thought we would go through a little example. Obviously, the way that one might start with a search like this is to put something in like nuclear receptors. But it's good to know that, again, because nuclear receptors is going to hit across a lot of different information sources, sometimes you can actually use those information sources to help you query for additional things. So this shows you, and I know it's a little bit small, and I hope that you feel free to follow along yourself. This hits us into community resources. Over on the left are the categories of information that are available, and down below it tells you a list of the sources that are available to you. You'll notice that these things look a lot like Google search results. In fact, these are individual records that come from these individual databases. And if you look down here, it tells you what the source is. If you want to look, for example, this is coming from something called the antibody registry. If you'd like to look at all the information from the antibody registry, whoops, you can either go down and use the source filter, or also here, click here to reveal a table. And a lot of us are used to looking at databases more as a table than as snippets. We allow you to go back and forth easily. Once you do this, however, you can pick some of these categories to refine. So here you see that there is a data category and something called molecule, and I think this next one is, in fact, what happens if you search for data and then look for molecular data. Actually, it takes you to NERSA, and here you find a list of molecules that are actually associated with nuclear receptors. And you can look at them right here. NERSA provides a filter that's called nuclear receptors. So if you wanted to start off your search for appropriate data sets by gathering a list of nuclear receptors and then putting that in your search bar, this provides a way for you to do that. It gives you a list of these receptors. Over here, you can download this as a spreadsheet. Unfortunately, it's not easy to go from here into the search, but you can download, copy those, put those into your search bar, and actually search for them, and there they are. Here's your list of receptors. So that would be one way that you would be able to go in and look. You could also use this type of search to find, for example, drugs that target, a list of drugs that target nuclear receptors, going in and, again, looking at some of the deeper data sources that we have. If you're in more resources, this is the same thing here, nuclear receptors. You could actually go into the more resources and say, well, that was great. I got a list of receptors, but I don't want a list of the data sets that NERSA has because those already exist. I want to find data sets that aren't here. So we actually have a beta interface that's available for the more resources, and here you see these categories in these boxes. When you select one of these, it acts as a filter. So here it says, I'm going to show you all of the data sets that we have associated with nuclear receptors that are related to molecules. And down here, it gives you a list of the databases that are actually available. And unfortunately, it's too small for my eyes to know what that says. So we'll go on to the next one. Right, so this actually turns out to be a proteomics database that has proteomics data sets that are available in the public domain. This is called Proteome Exchange, and it does give you a list of data sets that meet the search criteria. So here you see a set of data sets that Proteome Exchange says are related to this. dkNET is designed to give you a small view into this complex data source. So we pick a few categories. It's very hard to fit them all on the page. If you want to look for more columns, you see there's the expand button. But also if you click on the record itself, it will take you actually to the source. Also notice though, when you pick a data set over here, we give you some customized filters and things that help you actually navigate these sources. But dkNET is really designed to take you, not to replace these sources, but to take you to these sources, much as Google is. So if you click on it, it actually takes you into Proteome Exchange to that exact record. So you don't have to do your search again for most of the resources that we index, but you can go directly to that record. And here you can determine whether in fact this is an appropriate data set or not, and if so, you would add that accession number to your spreadsheet and then go ahead and load it up. Okay, so this is just one of the paths through dkNET. dkNET has a lot of sources, some of which you might not think could give you information, but for example, we do index NIH Reporter, which has all of the funded grants. We do the literature. There are other funky databases that people, colleagues and others have set up that we often index. And so we're really encouraging you to explore dkNET and use novel search strategies to be able to pull out this type of information. What was that? Time? Oh, okay, yes, so Koei is reminding me that we're running to the end, but we did start three minutes late. That pretty much is an introduction to the challenge and also how you use dkNET. If you go to the challenge page, there's various help resources there. Because we're searching across such a rich amount of diverse information, as Scott indicated, one of the very first things that happens is you might get too many results and some of those are not relevant. We provide a set of search tips how you can reduce those and just other ways of actually using and visualizing information inside of dkNET. So I think that's about it, right? These things will be available, the webinar will be available. But let me again ask if there are any questions.
Can we go to, yeah.
And if not, we wish you good luck in your searching. Feel free to help us. Oh, the scoring. We didn't talk about the scoring. So we should say that there is a scoring system that we have developed in conjunction with NERSA for how the data sets that you submit are scored. You get 1 point for each correct field. So, you know, for $500, you got to work a little bit. The repository accession number needs to be there, but points are awarded only for data sets not currently in NERSA. dkNET can help you a little bit with that, but again, you want to make sure. But of course, since dkNET is involved in this, you get extra points if you actually use dkNET at any point during your search. You need not end up there, but you should either start there or go back to it in the middle. And if you detail to us in that field that Koei mentioned how you use dkNET, you get extra points for that. And if you provide us feedback, you also get extra points for that. So on the challenge, what was that challenge site, you can upload your results. You can upload them as you go, or you can save them all to the end and then upload them. It actually runs through June 16th, and I think that date needs to be a little bit bigger. Okay, and we will again be happy to help you at any time during this, even though you know, we want you to be clever in how you go. If you run into any problems, feel free to contact us. We do have a hashtag, and we will regularly post information to our fact page and to our Twitter stream. And I think I already mentioned that, right? There are many other sources than what you might think about to go and look for these things. The information is ferreted away. So the more you delve in, the more creative you may become. If you're interested in more in-depth information on how to use dkNET, we actually are holding a dkNET introductory webinar on May 10th. That's going to go much more deeply into the types of sources dkNET has and introduce some of the advanced features. And we really hope you'll invite your friends and colleagues to join. It shouldn't take a whole lot of effort, and you will be rewarded for your efforts, not just by the prizes, but also, again, I think it's really a good introduction to these new types of resources that are being created, the data resources. I should also say, and I think it's going to be in the facts if it's not already, you don't have to get the data set, right? You just have to point out where it is described so that the NERSA curators can go and get it, right? So you don't have to submit the data set itself, just metadata about the data set. So thank you all for joining in.